Hey everybody, this is Professor Trailer, and let's talk about remote sensing and why that's important to us as drone pilots. So remote sensing is the science of acquiring information about the Earth's surface without actually being in contact with it. This is done by sensing and recording the reflected or emitted energy and processing, analyzing, and applying that information. Now the process involves interaction between the incident radiation and the targets of interest. We do this with RGB cameras, infrared sensors, multispectral sensors, and LiDAR systems, uh, and several others that are out there. Small aperture radars, things like that, synthetic aperture, and it goes on. So that this imaging, the use of imaging systems follows 7 basic elements, and we're going to learn about those elements today. So the first is we need an imagery source or an illumination source that provides electromagnetic energy for the target of interest. This radiation is going to pass through the atmosphere, and as the energy travels from its source to its target, how does that interaction occur? The interaction takes place a second time as it's going to travel from the target to the sensor. Now, the interaction that takes place once the energy makes its way to the target through the atmosphere depends on the properties of both the target and the radiation. Uh, so this will also affect the recording of the energy by the sensor. After the energy has been hit or scattered or by the target or emitted by the target, we require a sensor remote not in contact with the target to collect the data. Now this depends greatly based off the composition and characteristics of the target. So, for example, a black asphalt road, it will absorb a lot of heat energy and maintain that and reflect that, which would be very easy to see using an infrared system, but may not be using a RGB camera. It'll just show up as a black road, but you'll see a lot more thermal activity on that. So think about this when you're looking at cameras and images. What we're seeing based off, and even with our eyes, is our eyes are uh, detecting the reflected visible light spectrum. So we're doing this process all the time. So we're recording that information uh, with our with our eyes. Same thing we're doing it with our systems. They're going to transmit uh, for processing. So the energy recorded by the sensor has been transmitted often in an electronic form to a receiving and processing station where the data is going to be processed into an image. This would be taking, basically like the SD card out and putting it into some software that's going to produce a product for us. Because for a great example of this is farmers when they're doing multispectral analysis of the fields, you can't see the differences sometimes, but the camera can pick that up, and it requires a computer to do the analysis. Same thing with LiDAR. LiDAR, you can't see it, but what it's using a laser sweeping over the area, and that which is an active sensor, and it's detecting the actual topography of the area we're going through. So that needs a computer to process that all together, so we can do analysis and interpretation of what we're getting. This allows us to extract the information we need to be able to make decisions, which is the last part of that. This is application. So if the farmer does a multispectral analysis of his field and it finds that in the northwest corner he's got some plant health issues, he's getting multispectral returns that are different than the whole rest of the field, there may be a problem. So we're going to go out there and use that to assess the problem and then come up with a solution. Now, sensors come in 2 different varieties. One is a passive sensor. These are measuring energy that's naturally available. We're not trying to emit any additional information or energy out. We're just gathering what's there. It's really dependent on day or night, in time of day, time of year, because even with time of year, the amount of energy that's available is different. think about this. So on June 21st, it's the summer solstice. It's the longest day of the year. So we're going to have the most direct sunlight from the sun, which is providing energy to our area. So we're getting the most energy, often when we're at our warmest. Excuse me. Compare that to December 21st, which is when we're at the furthest. We're receiving the least amount of energy. So that kind of varies based off of season, time of day, year, things like that. So for what's just naturally occurring. So there's going to be variances from that. Energy is naturally emitted and detected day or night as long as there is a sufficient amount of energy to be recorded. This includes thermal infrared images. Here we have two thermal infrared images of the same location, but one is in black hot and one is in rainbow. And as you can tell, there's a little bit of variation of information that's being gathered here, where we've got color spikes in certain locations, a little bit more detail in the rainbow versus the white hot. So you can play around with those sensors and gather additional data just in the spectrums we're looking at or color palettes. Active sensors provide their own energy for the source of illumination. These are like your LiDAR systems that are sending out a beam of radiation and measuring what's being reflected back to it. This isn't dependent on time of day, season, or anything like that. It's providing its own illumination and used for determining sometimes wavelengths that the sun can't provide, such as microwaves, so to better control the way the target's illuminated. Now, to gather the data, its critical component is to have the energy, the recording of the energy done by a sensor that has a stable platform that's removed from the target or their surface is being observed. This can be ground-based, large trucks that have elevated sensors such as trucks with booms, aircraft-based, typically fixed-wing crewed aviation, so tends to be a little bit more of a stable platform versus helicopters, or uncrewed aviation, either fixed-wing or VTOL aircraft tend to be very stable for gathering that information, and then satellite-based, space-based satellites. So here's the lecture and discussion question. So remote sensing for UAS, what are some advantages for using small UAS for conducting remote sensing operations? What are some disadvantages? And provide examples of what we're talking about for the discussion board. So that'll be the discussion board for this module. And if you have any questions, please feel free to reach out to me and let me know.